Hello students, we will do some problems on Fourier transform and Fourier series. So the first problem is develop a Fourier transform, a Fourier series for the sawtooth or ramp wave. It is fx is equal to x by L. X is between minus L and SL. So if this is the function fx, it looks something like this. The values are minus 3L, minus 2L, L, 0, L and 2L. So the Fourier transform can be written as this is the function. So we can write fx as equal to 1 by 2a0 plus summation n is equal to 1 to infinity an cos n by x by L plus bn sin n by x by L. So where an is equal to 1 by L to minus L to L fx cos n by x by L dx and en is equal to 1 by L minus L to L fx sin n by x by L dx. Now you know that fx is equal to x by L, so f minus x is equal to minus x by L, which is equal to minus fx, so it is an odd function. So therefore, hence we can say that for an odd function an is equal to 0 for all n. So we are only left with bn, and that is, again we can write, let's write, we can also write, we can expand it, we can write it as it is equal to 2L 2 by L two by L 0 to L x sin n by x by L dx. So what we have done is that we replaced x by x by L, so dx will be dx by L. write it as Bn is equal to 2 by L 0 to L Bn is equal to 2 by L 0 to L x sine n pi x by L dx. So it is equal to again minus 2 by n pi cos n pi so it is again equal to minus 2 by n pi minus 1 is equal to 2 by n pi minus 1 n plus 1. So therefore you can write fx as equal to 2 by pi summation 1 to infinity minus 1 n plus 1 divided by n into sine n pi x by L. So that is again equal to 2 by pi into sine pi x by L minus 1 by 2 minus 1 by 2 sine 2 pi x by L plus 1 by 3 sine 3 pi x by L, and the series goes on. So if we draw the graphically, so for the first 3 terms, it will look like this. For the 3 terms, for the next 6 terms, it will look something like this. Terms, and for the 9 terms it will be even more denser. The 9 terms. So what we can see is that when the number of terms increase, a better agreement is obtained. So here, if we superimpose the sawtooth plot, so this is the sawtooth plot, original function, original sawtooth plot. This is how it looks. So in that case, it is. So we can see as the number of terms is increasing from 6 terms to 3 terms to 6 terms, so agreement with the function is reached. So we can have a general rule which says that uh, if the original function is smoother compared to so if the original function is smoother, then the like in this case, then the convergence of the Fourier series is much rapid. The convergence of the Fourier series is much rapid, and only a few terms are required. And similarly, if a highly discontinuous function, if the function is highly discontinuous, that can be approximated with reasonable accuracy. It can be approximated with reasonable accuracy only with large number of terms. Only with large number of terms. So these are two main rules. Now coming to the second problem, and the problem is you have to find the Fourier series of the periodic function, which is defined by the following condition: if fx is equal to 0, if x lies between minus pi and 0, and it is equal to pi if lies between 0 and pi. So to find the Fourier series of the following function. So you can see that this fx is again defined in the interval of minus pi to pi. So this is the interval. So we can write the Fourier expansion fx as equal to 1 by 2a0 plus summation of n is equal to 1 to infinity an cos nx plus bn sin nx, where we can write an is equal to 1 by pi minus infinity minus pi to pi fx cos x dx, and a0 as equal to 1 by pi minus pi to pi fx dx. equal to 1 by pi minus pi to pi fx sine nx dx. So we can write a0 as equal to 1 by pi. As we know that the condition is, if it is between minus pi to 0, the function is equal to 0, and if it is between 0 and pi, then function is equal to pi. So in that way we can write a0. So if it is minus pi to 0, the function should be equal to 0. So 0 into dx plus summation 0 to pi into pi dx. So ultimately a0 comes out to be equal to pi, and similarly we can have an is equal to 1 by pi 0 to pi cos nx dx, and it is equal to 0, and n is greater than or equal to 1. And next we can have a bn is equal to 1 by pi integration 0 to pi sine nx dx, and it is equal to 1 by n into 1 minus cos n pi. So using all this information gathered, we can write the function fx as equal to pi by 2 plus 2 into sin x plus 1/3 sin 3x plus 1/5 sin 5x. Okay. So the an part is equal to 0, a0 is equal to pi by 2, a is equal to pi. So the first term is of course so this is the first term. So if a0 is equal to pi, so the first term is pi by 2, and this part is equal to 0, it totally vanishes. So we have bn sine nx, and we have found that the value of bn to be equal to 1 by n cos 1 minus cos nx. So again, so it will be 1 by pi. The first one will be sin nx, so this is sin nx, then 1/3 of sin nx, 1/5 of sin nx, if we do the integration from 0 to pi. So the graphical representation, if we do the graphical representation, it will be something like this. So the function was suppose this is from minus pi 0 and pi. So function was the function since it has the value 0 till It is between 0 and minus pi and its value, and if this is pi, so it has got a value pi. So this is how the function was, a step function type. And so the Fourier transform function is something like this. For n is equal to 1, it is like this. For n is equal to 2, like this. For n is equal to 3, like this, and so on. So it keeps on increasing. So this is for 2, this is for 3, and so on. This is for 1. Now in the original function, the discontinuity is actually occurring at x is equal to 0. So this is the place where it is the discontinuity is taking place in the function, and the series actually is reducing to, so fx at x is equal to 0, the series is actually reducing to pi by 2. That means the first function. Now we can write pi by 2 as equal to 1 by 2 into function of 0 towards the negative side plus the function of 0 towards the positive side. So this condition is actually continuous with the Dirichlet's theorem. That means the function should itself be continuous. And the similar behavior is also exhibited when the value of x is pi and let's say 2 pi. So we can write y as equal to pi by 2 in the y-axis, and also we can write is equal to pi by 2 plus sine 2 sine x for the first case, for n is equal to 2, and again pi by 2 plus 2 sine x plus 1/3 2 into sine x plus 1/3 sine x, and then 1/5 sine 5x, so on and so forth. So this is how the series keeps on going. Now based upon this result that we obtained, if the following square wave function, so this is actually a square wave. Initially it was a step function or square wave, whatever you can call it, and if you are asked to prove that 1 minus 1/3 plus 1 by 5 minus 1 by 7, and this is equal to pi by 4. So this is the problem. So take it as problem number 3. So we can do it by the following way. We have what we have obtained in the previous problem is y is equal to pi by 2 plus 2 into sine x plus 1/3 sine 3x plus 1/5 sine 5x plus 1/7 sine 7x is the condition. So we put x is equal to pi by 2, then we can have pi is equal to pi by 2 plus 2 into 1 minus 1/3 plus 1/5 minus 1/7, so on and so forth. So hence we can have pi by 4 is equal to 1 minus 1/3 plus 1/5 plus minus 1/7 dot dot dot. So this is the only thing that we have to do. We have to put x as equal to pi by 2. So next problem is find the Fourier transform. Now we from Fourier series move on to the Fourier transform. So if somebody tells you to find out the Fourier transform of the function fx is equal to 1 when the mod value of x is less than a, and it is equal to 0 when the mod value of x is greater than a. So you can first write the Fourier transform. Well, let's say the Fourier transform is given as tu. So tu is equal to 1 by root 2 pi minus a to a e to the power I ux fx dx, and that is equal to 1 by root 2 pi minus a to a now what we will do, we will take this condition that if it is less than a, so the mod value is less than a. So that is why we have, instead of writing minus infinity to plus infinity, here usually we write minus infinity to plus infinity, but since the value is 0, so it's no point in taking. So the interval is between minus a to plus a, and so it will be I in any way the function remains as 1, and it will be I ux into dx. So by simple integration it is equal to 1 by root 2 pi, integration will be to the power I ux divided by iu minus a to a, and it is 1 by root 2 pi e to the power iua minus e to the power minus iua divided by iu, and it is nothing but sine. Let's go to the next step. So what we've obtained is, we obtained 1 by root 2 pi e to the power iua minus e to the power minus iua divided by iu. So it is simply root 2 by sine ua by u, where u is not equal to 0. So for u is equal to 0, so this is actually equal to sine 2i sine ua. So I cancels out, and from 2 multiplied here 2, so 1 by root 2 pi will be 1 root 2 by pi, and this is how we get. So u is equal to 0, and tu is equal to 2 by pi into u if u is equal to 0. So again, if we draw the plot, so the original function is like this. So it is if this is equal to 0 and this is 1, so this is 1, so it's called a slit function. X is equal to 1 for a particular value of a. And the Fourier transform is a sinusoidal function. It is sine ua by u mainly, so it looks something like this. So this is your tu and this is your fx. So this value is minus pi by 3. This is also pi by 3, and this is 2 pi by 3. This is minus 2 pi by 3. Now this Fourier transform has got very good application in what is known as Fraunhofer diffraction. Which is given by f omega. F is equal to a sine alpha by alpha. This is Fraunhofer diffraction pattern due to a single slit. So if you again look into the Fourier transform, so this is where is the maxima or the highly intense beam will be, and these are the minima, low intensity. So this is what the question is all about. The next problem is to find out the we need to have Fourier transform or Fourier integral, whatever we may call it. We need to use the Fourier integral to prove that 0 to infinity cos ax dx divided by 1 plus a square is equal to pi by 2 e to the power minus x. So this is the problem. So first we will use the Fourier integral theorem. So fx is equal to 2 by pi 0 to infinity cos ax dA into 0 to infinity e to the power minus u cos AU du. Now we will put fx as equal to e to the power minus x, and then 0 to infinity e to the power minus eu cos AU du will be equal to b divided by b square plus a square. So here 0 to infinity e to the power minus u cos AU du it will be 1 by 1 plus a square, and therefore we can have 2 by pi 0 to infinity cos ax divided by 1 plus a square dx is equal to fx, or 0 to infinity cos ax divided by 1 plus a square is equal to pi by 2 e to the power minus x. So the next problem is the Fourier to show that the Fourier transform of the normalized Gaussian distribution of the normalized Gaussian distribution is ft is equal to 1 by put it as tau into root 2 pi e to the power minus t square by 2 tau square, where t is between minus infinity and plus infinity, and this is another Gaussian distribution. So from one Gaussian distribution, the Fourier transform is another Gaussian distribution. So the Gaussian distribution is now centered at t is equal to 0, which is why it is centered. So we can write f omega is equal to 1 by 2 root 2 pi minus infinity to infinity ft into cos ft into e to the power minus I omega t dt. This is the Fourier transform, and so if we expand it, it is 1 by root 2 pi minus infinity to infinity 1 by tau root 2 pi e to the power minus t square by 2 tau square e to the power minus I omega t dt, as it is 1 by root 2 pi into minus infinity to infinity 1 by tau root 2 pi into e to the power minus t square plus 2 tau square I omega t plus tau square I omega whole square minus tau square I omega whole square into dt, and so that turns out to be 1 by root 2 pi e to the power minus t square omega square by 2 into 1 by tau root pi into, again there will be integration, minus infinity plus infinity e to the power minus t plus I tau square omega square whole square divided by 2 tau square dt. And this expression here, this expression here in the bracket is equal to 1, as it is the integral of a normalized Gaussian distribution. So if it is integral of normalized Gaussian distribution, so this integral has to be equal to 1. So what we will ultimately get, we will get this term. So we can write again f omega as equal to 1 by root 2 pi e to the power minus t square omega tau square omega square by 2 which is another Gaussian distribution centered on 0, another Gaussian distribution again centered at 0 and having a square deviation of 1 by